So now the quotient rule. Now the quotient rule, admittedly, is probably a calculus student's least favorite derivative rule because it's a bit painful. But a lot of times we do need it. Sometimes we can get out of it and do a product instead. We'll see that. But here we're going to presume that we need to use it, and we'll see how it's structured. So if I want to take the derivative of the quotient f of x over g of x, right? What it's going to come down to is the derivative of f of x times g of x as it is minus, notice the difference from the product, minus f of x as it is times the derivative of g of x all over g of x squared. Okay, that's not obvious at all. Now notice the numerator does look like the product rule, except it is a minus in there. So it's similar. And then you have g squared on the bottom. Again, probably easier to remember in the prime notation. So if I do take f over g and do the derivative, it's f prime g minus fg prime over g squared. There's a lot of ways that people remember this. The way I look at it is I usually say this to myself. The derivative of f over g, I think top and bottom. Okay, so I think the derivative of the top times the bottom, as it is, minus the top times the derivative of the bottom over the bottom squared. So that's how I remember it in my head. All right. Other people, when I was taught it, I think I was taught it as looking at the top as high and the bottom as low. So you would say low d high, that would be low d high minus high d low over low squared. But I don't remember that that way. That's why I struggle to put it into practice there. Ultimately, you have to find what helps you remember that. But when I do it, I'm going to say derivative of the top times the bottom as it is minus the top as it is times the derivative of the bottom over the bottom squared. Okay. So again, it's just a routine that you have to get used to. So here we go. Here is the top, 3x minus 2. Here is the bottom, 2x plus 5. If I want the derivative of this quotient, I'd say, and again, so I'm going to do it in long form here of showing each step, and I may in the future start skipping ones. Derivative of the top times the bottom as it is minus the top as it is times the derivative of the bottom all over the bottom squared. Okay, we're not going to leave it like that. We got to go further. So let's go back up here. The derivative of the top is 3, because it's the derivative of 3x is 3, and the derivative of the minus 2 is 0, times 2x plus 5 as it is, minus 3x minus 2 as it is, times the derivative of 2x plus 5, but again, that's just, the plus 5 is going to give us 0, so it's only a derivative of 2x, which is going to give us a 2, all over 2x plus 5 squared. Now, good question is, how far should we go in simplifying this? Well, we certainly should group like terms. We should expand the top and group like terms. Let's see where we can go from there. 6x plus 15 minus, so realize I'm distributing the 2 over here. If you don't like the look of this, you could have just put this 2 in front before starting this multiplication. All right, so I get minus 6x, and then remember I do have a minus here, so it's minus 2 times minus 2 plus 4 over 2x plus 5 squared. Okay, I should go a little further because I noticed that 6x minus 6x cancels out, which is not actually coincidental here. You'll see this when you have a linear over a linear. There's often cancellation such as that. Okay, so then I get 15. I get 19 over 2x plus 5 squared. There's my answer. Okay, so that wasn't too bad. It's a lot of work, but fundamentally it's not too bad. All right, let's do one a little bit differently. A different example. All right, so we have the top is x, the bottom is cosine x. So remember, we have the derivative of the top times the bottom as it is minus the top x times the derivative of the bottom all over the bottom squared. Okay, so the derivative of x is just 1, and I still have cosine x there, minus x as it is. Now the derivative of cosine x is minus sine x. And then I have over, and I'll use the shorthand notation, cosine squared x, so that I can write it without the parenthesis. Parentheses. Okay, so let's clean this up a little bit. I get cosine x minus, so plus x sine x over cosine squared x. That looks good to me. I think I'll leave it like that. Doesn't look like there's any simplification. I should look to see if there's a factor I could pull out. May or may not be necessary to do that. Or I could look for some trig identities, but I don't see anything in there, so that's good. We're going to see that, again, like previous problems, what form you put it in really depends on what you want to do with it later on. Okay, so if I'm just getting the derivative, then this seems fine. If I'm trying to solve this in an equation, because later on what we're going to do is we're going to take something like this derivative and say set it equal to 0 or something like that. And we'll see that we might want different forms for it in that circumstance. But right now, this seems good to me. All right, so that's the quotient rule. So the product and quotient rule are just procedural, but you have to get comfortable by doing a bunch of problems. Okay, I'll do a few more of these in a little bit on a worksheet, but that's it on this for now.